Okay, so this is the fourth video in the series of rate and rate equations and kinetics for A2 chemistry. We're going to look now at some past paper questions. I've plucked out a few here which sort of cover, I suppose, possibly the more challenging questions that you'll get, but I've done plenty of more straightforward ones through, especially through video number 3. So let's start. Again, guys, you can pause the videos, have a look at these yourselves and try and do them. You should be at the point now where you should be able to do that. And when you do that, then you can hit the play button again, see if you get the right answer. So I'll work through them very quickly. I'll bring the question up, I'll pause for a few seconds, let you pause it, and then I will start my working out. So, just check that's the first question. So this is the first question. We've got to work out which of these numbers is the correct number to go into the box. So let's have a look. This was kind of very much the stuff that I was doing in video number 3. So let's look at working out value A first of all. So we've got the rate equation up here, very important. Don't ignore it. Okay. So we're trying to work out what is happening to the rate. So that's, I'm going to put my question mark in there. Rate. If we look at the change for x, x is changed by a factor of 1, so that is 1 to the 1 because it's first order, multiplied by y. Y has doubled, okay, so therefore that is 2, it's first order, so 2 times 1, so the the rate has doubled, so that would be 2.4 times 10 to the minus 4 there. The question for A is, it has a value of 4.8, 10 to the minus 4. Well, A, we can rule out that is incorrect. Let's move on to B. Okay, so for B, let's have a look at experiment 1 and experiment 3. I'm not taking experiment 2 and 3 because the concentration of Y has also changed in that. I want something where only the concentration of X, okay, can be investigated. So Y from 1 to 3 has gone up by a factor of 1. The rate has gone up by a factor of 2. So let's plug in my values. Rate has gone up by a factor of 2. X has gone up by a factor of, well, that's what I'm trying to work out. Okay, it's to the 1. And Y has gone up by a factor of 1 as well. And that is 1 to the 1, which is, of course, 1. So if I rearrange that, 2 divided by 1 equals the change in x to the power of 1, so which is 2. Okay, so therefore x has doubled, so x should be, B in this instance, will now be 0.04. We can see that B is indeed 0.04, so the answer to this one would be B. Let's just prove that the others are incorrect while we're at it. Okay, that's a valuable exercise as well. So let's look at, we'll do experiments 1 and 4 for this one. So if we can see X has doubled, Y has tripled, and we're looking to work out what has happened to the rate. Okay, so we're going to go question mark equals X has doubled, so that's 2 to the 1, which is 2, multiplied by Y has tripled, that's 3 to the 1, so therefore the rate has gone up by a factor of 6, so it's gone from 1.2, 10 to the minus 4, okay, it's gone up by a factor of 6, let me get my calculator, 1.2, 10 to the minus 4 times 6, so therefore the new rate should be 7.2 times 10 to the minus 4, not 6 times 10 to the minus 4. Let's do the last one just to prove that it is incorrect as well. So we'll just take experiment 1 and 5. So X has tripled, yep. Y, that's what we're trying to work out, and that has gone up by a factor of 6. I'm just doing that off the top of my head. I'm pretty sure that's right. Okay, so let's go. Rate has gone up by a factor of 6. X has gone up by a factor of 3 to the 1, which is 3. And Y, well, that's what we're trying to work out. Okay, so 6 divided by 3, which is 2, equals X to the 1. So therefore, X has, along there, it has doubled, so it should be 0.04. The question says it should be 0.06, or the answer says that, so that is, of course, wrong. Right, let's look at this one. Again, pause the video if you want. Have a go at it yourself. Right, so we're trying to find the orders with respect to this. So that has gone up by a factor of 3. Okay, this has gone up by a factor of 1. And this has gone up by a factor of 3. So, therefore, my dichloroethane is definitely first order, so I can rule out D, only D. Okay? Now, this is one of these nasty ones where the other reactant changes in all experiments. So I need to factor that in. I'm going to look at experiment 3 versus experiment 4. So here, this has halved, this has doubled, and this has stayed the same. Now, those of you who are mathematically on the ball will be able to work out that if one's first order and it halves and the other one doubles and the rate stays the same, that actually both of them are first order. Those of you who aren't quite so mathematically astute, okay, I will explain. So, rate has gone up by a factor of 1 equals the dichloroethane has gone up by a factor of a half to the 1, which is halved, in other words, and our chlorine has doubled to the x. X is what we're trying to find out the order. So 1 over a half is, of course, 2 equals 2 to the x. X must be 1, first order. The answer is B. Okay. That is the same question as before, so we're not going to do that. Okay, again, let's have a look at this one. Here, if we look... let's see, yeah, okay, so for this one, I'm going to look at experiment 2 and experiment 3. Okay, so that has doubled, that has stayed the same, and here to here, let me just double check this on my calculator. So minus 1 divided by 4.43 10 to the minus 2. Okay, so that's gone by a factor of 4. So that means this is double factor 4. Therefore, that is my nitrogen monoxide is second order. Okay, so that's definitely second order. Let's have a look at my hydrogen. We can see all of these are always changing, so that's a bit of a pain, but we just got to deal with it. Okay, so we will put in our rate. We're going to use experiment 1 and 2. I can't use 2 and 3 because hydrogen doesn't change 2 to 3. That would make no point. I could use 1 and 3 if I wanted. Okay, so but we're going to use 1 and 2. Okay, so let's see, 4.43 times 10 to the minus 2 divided by 2.46 times 10 to the minus 3 gives me a change there of 18-fold. Okay, so my rate has changed by 18 equals my nitrogen monoxide has tripled from 1 to 2. Okay, and now that was second order. We already so 1 to that is therefore 3 to the power of 2, which is 9, multiplied by this has my hydrogen has doubled, and we're trying to find out what x is. So rearrange 18 over 9 equals 2 to the x. X has to be first order, so that is first order. Okay, let's look at this one. Okay, I'm not working out the K values here, guys. I think working out the K value from once you get the rate equation really should be very simple, and you have tons of past paper questions that you can do to do that. Right, let's look at this one. What's the challenge here? Well, let's have a look. Everybody always wants, because you're so used to working left to right, everybody wants to work out the H2PO2 minus ion here, okay, the phosphonite ions, but we can't do that here. We've got to go to the hydroxide this time, first of all, okay, because the hydroxide is always changing. We cannot work it out first. So we're going to look at experiment 1 versus experiment 2. This has remained the same, this has doubled, and this has gone up by a factor of 4. Okay, right, so therefore, hydroxide ions have doubled, the reaction's gone up by a factor of 4, so that's 2 to the 2. Okay, so therefore that is second order. Right, let's go and find, so we know that OH minus here is going to be second order. we'll just put in rate equals K. Now we've got to find our phosphonite ions. How do they change? So let's take experiment 2 and 3. So they have doubled there. This has gone up, the hydroxide ion has gone up by a factor of 1.5. Okay, and this has gone up by, let's work it out, 43.2 divided by 9.6. That's gone up by a factor of, let me just check that, it looks funny, 4.3 divided by 9.6. Yeah, that's gone up by a factor of 4.5. So let's plug those values in. My rate's gone up by 4.5. Okay, my H2PO2 minus phosphonite ions have gone up by a factor of 2 to the, that was second order, wasn't it? Okay, 2 to the 2, which is 4. Okay, and these have gone up by a well, I'm trying to work, so they have 1.5. Okay, and we're trying to work out what X is. Let's do that. 4.5 divided by 4. 4.5 divided by 4 is equal to 1 point, so we have got 1.125 equals 1.5 to the X. Okay, I'm going to start that one again because I've made a silly mistake. It was the hydroxide ions that were second order, not the H2PO2s. So that was my fault. Okay, so they are second order. Okay, let's start this again. Right, so we're going to look at experiment 2 to experiment 3. This has gone up by a doubling. This has gone up by a 1.5, and this has gone up by a factor of 4.5. Okay, so my rate has changed by 4.5. My H2PO2s have gone up by a factor of 2, and my hydroxide ions have gone up by a factor of 1.5, but that is 1.5 squared, which is 2.25. So 4.5 equals 2 multiplied by 2.25. Okay, or I should say 2 to the X actually, because that's the volume I'm trying to work out. So if I go therefore 4.5 divided by 2.25, which is equal to 2, equals 2 to the X. X value is 1. We got there eventually. Okay, so deduce the rate equation. The rate equation therefore is rate equals K to the H2PO2 minuses their first order, and my hydroxide ions are second order. Okay, the overall order is third order, 2 plus 1. Calculate the rate constant. Okay, well, I'll just take the first experiment there, and the first experiment is okay equals 2.4. Okay, divided by 0.1 multiplied by 0.1 squared. So I always do the bottom line first. 0.1 squared multiplied by 0.1 is that. 2.4 divided by that gives me, I have that at 2400. Okay, units would be moles to the, I'm going to do this off the top of my head so I may get it wrong. I have moles, yeah, I have moles to the -2, dm to the 6s to the -1, I think, off the top of my head. Hopefully that's right. Oh, right, okay, let's have a look at this one. Right, so this one is another one kind of like similar to earlier where I couldn't work out the change for the order for A straight off because B is constantly changing. So I'm going to do B first, right. I'm going to take experiment 1 and experiment 2. That stays constant, C stays constant, B has changed, the rate has stayed constant, so that I can really quickly work out B is 0 order. Don't need to do any maths at all. B is 0 order. That means I can get rid of A and I can get rid of B down below. Okay, let's go and look at where I'm going to work out for A this time. So B is 0 order, so it's irrelevant. I can ignore it completely. Doesn't matter whether it changes, it doesn't affect the rate. So let's look at experiment 1 and experiment 4. Okay, so if I go from here, I'm going to go back from 4 up to 1. That changes by a factor of 10. That changes by a factor of 1, so it's not affecting the rate. And if I go from there back to there, that is also changing by a factor of 10. That's directly proportional. So therefore A is first order. doesn't actually help me. Okay, if I'd have had my brain switched on, I would have realised that, and I would have gone and worked out C first of all, because C and D both have A as first order. Right, let's go and find C now. Okay, so C, I'm going to take experiment 1 and experiment 3 because A remains constant. Okay, and C from experiment 3 back to 1 has doubled. Okay, so that has doubled. So let's go 3 back to 1. That is 9. Okay, so that has also doubled. 9, if you do it in your calculator, 1.8 10 to the minus 4 divided by 9 10 to the minus 5 is a doubling. So therefore it is double concentration, double rate. C is first order. The answer is C. Okay, last one. Okay, I might do some more in another video, but I think this video has now run into 15 minutes of past paper questions. That's more than enough for most people, I would think. Right, let's have a look here. We're going to look at the order with respect to C4. So I'm going to take experiment 1 and 2. That has doubled in that direction, and it has doubled in that direction. Therefore, it is first order. Okay. Let's look at the next one. Again, we've one of these tricky ones where everything on the other reactant has changed. So I'm going to take this time experiment 2 to 3, where that has tripled and that has doubled and that has tripled. Now, if you're on the ball, if reactant 1, the C4H9Br, has tripled and the rate has tripled, okay, that means that this must be zero order, okay, because it cannot be affecting the rate, okay. We've already worked out that C4H9Br is first order. Okay, I could, if you wanted, okay, I can go rate has gone up by a factor of 3. Okay, my hydroxide ions have gone up by a factor of 2 to the 2 to the x, yes, and my C4H9Br has gone up by a factor of 3 to the 1. Okay, and if I did 3 divided by 3 to the 1 equals 2 to the x, the only thing x can be there is, of course, 0. Right? If I wanted to write the overall rate equation, that's simply going to be rate equals K C4H9Br, sorry, excuse my handwriting, to the 1. You don't have to put the 1 in, and you definitely don't have to put the hydroxide ions in because they are zero order. Okay? Calculate the value for the rate constant. Well, that would simply be 40 divided by 0.02. What did I say? That was first order. Okay, equals whatever that equals. Okay, right. I think that is enough past paper questions done by me. You need to get the booklets, get stuck into them, get them marked. Any questions that you do have, please ask for help. But I think I've covered pretty much every base there.